Hello dear audiences, this is Probability and Statistics for Engineers, episode 12, and I am Mohammad Momenzadeh, the presenter of this course. So today we try to discuss about the remaining part of a discussion that we had it before. I mean the continuous joint probability distribution, and we will use the double integral over here severally. So if you just take a look at the contents that we have it, we started with the random variable. We discussed about the probability distribution, the discrete random variable, continuous random variable, and cumulative distribution. And later on we discussed about the joint probability distribution for all of these cases. So I think that we will solve only one example today, but before that we go into that example, let us see the concept of the joint probability distribution for the continuous cases. So I put the example and the definition over here. The function fxy is a joint probability distribution function or density function of a continuous random variable x and y if three conditions holds true. So these three conditions are as the same as the conditions that we have it for P.D.F, for the discrete, P.D.F for the continuous cases, and P.D.F for the discrete joint discrete distributions. Over here we just modify the situation. The first one determined that the function should be positive, in the means that the value of the function at the given point x and y should be positive. The second one determined that the double integral of a function over the given region from minus infinity to plus infinity over all region that we have, it should be equal to 1. And the third one determined the property of that function which connect the meaning of the function to the probability, means that probability of x and y belonging to that region is as the same as the double integral of a given function for any region. So we have this example, and as I said it, I think that we will discuss about this example from the beginning up to the end of this lecture, if I can finish it actually. So let us take a look at the example. Mainly when I just gave this course to the students, I gave them one question like this in a midterm exam, and it takes a lot of time for them to solve that type of the question. So let us take a look at this question. Let x denote the reaction time in seconds to a stimulant, and denote y the temperature at which a certain reaction starts to take place. Suppose that two random variables x, y have the joint density as follow. So at the beginning of this question, we want to verify that which value of k can lead us to the probability distribution function, means that we should take a double integral from the given function to calculate the value for the k. So at the beginning of the question, we try to solve that type of the question by taking the integral, means that we just use the second property of a joint probability distribution function to calculate the value of k, means that based on a definition, the integral from minus infinity to plus infinity, or all region that we have, is a double integral indeed of the function, should be equal to 1. So by using this concept, means that the double integral of fxy should be equal to 1, we can find the value for the given function. So it's important to determine the function clearly, so I just use dA instead of the dx dy. This integral should be equal to 1. So to solve this integral over there for the given function is here, we should know the shape of a function or the form of a function. So indeed, I just use some symbolic shape of a function, and later on I will show you the real case of a function as well. So over here, to have an illustration or visual shape for understanding the question, I just sketch one three-dimensional space, and I assume that the z equal to fxy is given by this surface, and this condition that is given in the question for the function means that this condition that we have it is given over here, and assume that we don't know what is that region at the beginning. So we have this region, and over the region the function is defined by z equal to fxy, and outside of this region the value of a function is equal to 0. So to calculate the double integral of fxy dA, we need to calculate indeed the double integral of this function over the given region. If I denote that region or that domain by d, means that I'm looking for this value over the domain of d, means that I should calculate the integral of kxy dA over the given region that we have it. So first of all, it's important to determine the region that we discuss about. It means that 2x greater than 0, less than 1 minus y, less than 1. I should know what is that region, and based on that region I should decide about the integral and the limit of the integral. This boundary of the integral should be calculated based on a given region. So let us take a look on that region and clearly determine that region as well. So first of all, let us sketch two-dimensional space and determine the region over two-dimensional spaces. So it means that again, I want to emphasize that indeed we just take a look at the bottom to that shape, means that if we just take a look on that region, I want to know what is the given region. Means that if you just take a look at the ground, we want to know what is the form of this region. So this is the question, the first thing that we have it. So for that reason, let us determine the given region by using two-dimensional space. So right now let us determine that region in two-dimensional space to calculate the given integral over there. So we have this inequality, and based on this inequality we want to determine the given region. So when you have the inequality, to determine the region, first of all change the inequality to equality to understand the border of that region. So we have 2x less than 1 minus y, so I just change that inequality to equality to see that what is the given region. So I just change it to equality, then I have 2x equal to 1 minus y, and for 2x equal to 1 minus y, for sure the shape of that region will be a line. So to sketch a line we need one t-table and find 2 points of a line as well. So I put in one side the value of x and the another side the value of y, and if I just replace the value of x, for example, by 0, then I will find the value of y corresponding to that case, which is equal to 1. So y is equal to 1 if x replaced by 0. Just put 0 over here, the left side will be 0, and shift y to the other side to see that the value of y is equal to 1. And again, if I put 0 for y to find the x-intercept now, if you put y equal to 0, then 2x is equal to 1 or x equal to half. And we have 2 points right now for the given line, so I can sketch that line. So one of them is 0 and 1, so 0 and 1 is located, for example, at this point. Let us put this value as 1, so one of them is here, and the another one, if I choose 1 over here, the another one is half, so the point half will be located here, half and 0. So we have 2 points, so if you connect them together, then you will find the given line as well. So this line, let us put the value over here, put the cases over here that we have it. 2x is equal to 1 minus y. So this is one of the line that we have it over there. The another thing that we can extract from the question is 2x is equal to 0 or x equal to 0. X equal to 0 is the another case, and another one that we can put it over there. The value that we have it over the last case means that 1 minus y is equal to 1, and this leads us to another line as well, which is y equal to 0. So y equal to 0 determine the x line and y line as well, means that we have the x line. For x equal to 0 we have the vertical line. This line, indeed, if I just sketch it here, this line over here, the vertical line or y-axis, can be determined by x equal to 0, and for y equal to 0 we have this actually horizontal line as well, so we can consider the y equal to 0 over here. I determine the border of that region by using some value that we have it, but don't fascinate over here to describe the region by this middle triangle. Maybe the triangle should be restricted more. To determine the region, I should know that what is the region for 2x less than 1 minus y. So to find this part means that for the equality we find that it's a line, but to know that what is 2x less than 1 minus y, we should decide about that this region should be considered at the left side of this line or at the right side of this line. So one of them is less, one of them is greater. So to calculate that one, the best point to examine the situation is an origin. So at the origin, the value of x is equal to y is equal to 0. So at the origin, the value of x is equal to y is equal to 0, and we can examine that value on an inequality. Means that right now 2x which is equal to 0 is in one side, and 1 minus y which is equal to 1 minus 0 or 1 is in the another side. So of course 1 is greater than 0, so means that this equality holds true at this region. So the region that we want it is laying at the left side of that actually cases. So for this reason, the left side of 2x equal to 1 minus y should be considered. So means that all region at the left side of that one should be considered as the part that we wanted. So based on this discussion that we had it over here, and based on a restriction of x equal to 0 and y equal to 0, this triangular part will determine the domain that we want to take an integral over that domain. Let us make it bigger over here to see that what's happened. Let me just erase this part. So if I erase this part, then I can use that region better. So it's necessary to determine the region clearly, otherwise you cannot solve the question. So let us take a look at this question again and put the value. So we have one value for the vertices, that the x coordinate is half and the another coordinate is 0. We have the another vertex over here, that is the origin, so 0 and 0, and the another point is given over here as 0 and 1. So we determine the vertices as well. One line that is given over here as a straight line that we have it there is 2x is equal to 1 minus y, and of course the another side are given by the another equation. One of them is that vertical line which is x equal to 0, and the another one is a horizontal line which is y equal to 0. So we determine the region clearly right now, and we can calculate the integral right now. So let us return back to the question to calculate our integral. So for calculating the integral, we can see that we have the domain as well kxy, I just determine both cases, that we have dx dy or we have dy dx. So let us write dx dy first, then I will write the same integral that is equal to the first one. You can choose any of them to calculate that integration. So we have kxy again, the function are as the same, but let us change the order of differentiation, means that we just write it as a dy dx. So for the first case, if we have dx dy, the order is as dx dy, then you should sketch the horizontal line to determine the integral. For the case that we have dy dx and the order is started by y, you should sketch the vertical line to determine the region. So if it's dx dy, let us see that what's happened. Just consider that you take a look at this domain. Let me denote it by D, at this domain as a farmland that you just take a look on it by a drone or by something from the top. So because it's dx dy, you should sketch the line in this direction. So it will be dx dy. And because of that, you should sketch the arrows like a horizontal arrows. And if you consider a person or a car or a farmer who want to enter to that region, it should enter from this border, means that this border is x equal to 0. So it started from x equal to 0. And it's coming out if the person is going inside of this region and wants to cross the outside border. There is only one border, that it's a bias line over here, and this bias line is given by 2x equal to 1 minus y, or x equal to 1 minus y over 2. So this is the border for the entry of the boundaries for that integral. And dy, for the dy, you should see that what is the range of y. Y is ranging between 0 up to 1, so I should put 0 and 1 for the y cases. If the region is given by dy dx, then you should sketch the vertical lines or vertical arrows. So if it's a vertical arrows over here and you want to enter to that region by the vertical arrows, means that it's dy dx, then the entry border over there will be y equal to 0. You should care about this. Sometimes you have two entry, then you should split the integral to two parts. But over here we have only one entry, one border to enter. For example, if the shape will be something like this, I mean the triangle shape like this, then to enter to that region you have two border, and for that reason you should split the shape to two parts and enter to that region from each side separately, and at the end of the day add these two integral to find the double integral. So you should care about this situation as well. But over here we have dy dx, and dy dx we just enter it with the border of y equal to 0, so the entry border is y equal to 0. And let us take a look at the output, means that if you enter from y equal to 0, again you should pass or cross this border, which is 2x equal to 1 minus y. And by calculating the things in terms of x, then y will be equal to, if you shift that one on the left side and 2x to the right side, then y equal to 1 minus 2x. So we have y equal to 1 minus 2x, and I will write it as a 1 minus 2x. Y equal to 1 minus 2x is a value that I should write it over here. And the value for the x in this case is determined by the restriction that we have it for x. As you can see, it's x started from 0 up to the point half. And here we just restricted the cases from 0 up to the point half. In this way we calculate, or we somehow evaluate the boundary or the limits of the double integral. So there are some actually trick that you can calculate that boundary without sketching the shape, but sketching the shape give you more accurate cases and you understand the integral better than that one. So what is that model of the calculation? If I just consider the inequality that we have it from very beginning, means that this is the inequality that we have it here. So if you just take a look, you can calculate the value for the x and y separately. Means that from here you can find the value for the x by dividing both sides by 2. Then we have x between 0 and 1 minus y over 2. 1 minus y over 2. So these are the boundary that we have it when we have dx dy. As you can see over here, the boundary that we had it, one of them is 0, the another one is 1 minus y over 2. So it means that you can use this one to calculate the boundaries. And for a y at the end of the day, we will use this inequality to find the value for the y. It means that 1 minus y should be a value between 1 and 0, and if you just multiply both sides by one negative sign, so it will be minus 1, then y minus 1. I just multiply the cases by minus 1, the inequality should be changed at the end, and then y by adding 1 to both sides, the left side will be 0 and the right side will be 1. So the y will be between 0 and 1, that we have this boundary over here. In the same way, you can calculate the values for the given cases for dy dx. Means that again, to calculate the limits of the integral for dy dx, we can use this inequality right now. Then 1 minus y should be a value between 1 and 2x based on that inequality. Right now, multiply both sides by one negative sign, so I should change the direction. Means that y minus 1, the minus 2x shift to the right, and minus 1 is at the left side. And if you add 1 to both sides, then we have y between 0, and if I add 1 to the right side as well, I have 1 minus 2x. And as you can see, this inequality determines the boundary of this integral over here. Means that you can use this technique to calculate the boundary of the integral for dy dx. And again, for the x value, you can find the restriction by putting a number. But keep it in your mind that always in double integral that we have it to calculate the value at the end, we should use indeed the numbers for the first integral over here, and use variables and numbers for the second limits of the integration. Right now we should calculate one of these integral because both of them give us the same value, so we should calculate one of them and then make it equal to 1 to calculate the value of k. So for this reason, let us calculate the second integral or first integral, doesn't matter. I mean, both of them give you the same value. So let us calculate one of them and see that what is the value for the given k. So I choose the second integral to be calculated, and again I just put the value 0.5 is the value that we have it for the first integral. Let us take a look at the second integral, I mean the linear integral that we have it, because it's dy, so the variable that we have it over here is y, and kx is a constant, so kx as a constant is coming out from the linear integral, and the integral of value of y is y square over 2, so I will write it as a y square over 2, and instead of the y I should replace the value in a limit of the integral. Means that the value are given by 0 and 1 minus 2x, and at the end of the day I should calculate dx. To calculate the integral, I should put the dx over there. Right now, instead of the y, I should replace 1 minus 2x, then I should replace it by 0. So if I put 0, 0 times anything else will be 0, so I have only 1 minus 2x. Then the integral reduced to this form means that I have the integral from 0 up to half of the given value when we have kx over 2, kx over 2, and for the value of y, as I said it, you should put 1 minus 2x, so we have 1 minus 2x. I replace it instead of the value of y, and totally square dx. Right now it's better to expand that expression. However, you can use the substitution method to solve it, but you can expand it. It's easier to calculate that value. If we expand the integral, the expression inside of the integral indeed, then we have the following things. We can put that constant outside of the expression as well. Let me just leave it outside of the expression, means that let me just shift this integral a bit to have a place to put them out. Right now k over 2 is a constant, so if it's a constant I can take it out from the integral. K over 2 is coming out, and then I have x multiplied by this expression. So this expression can be expanded as follows, means that I can rewrite it as the first one square minus 2 times of the first times second give us 4x, plus the second one square, which is 4x square. And at the end of the day I should multiply that expression outside of the parentheses one by one by the terms inside of the parentheses, means that we have these 3 multiplications. Then we will have this form of the integration. Let me just put a line over here to split the cases that we have it. So k over 2, the integral of 0 up to half, the value that I should put it over there, and the integral is as follow: x minus 4x squared, and the last one it's gonna be the 4x cubed. So we have 4x cubed. Right now we have a simple polynomial. To calculate the integral of this polynomial, we follow the formula for that, which is as follow, means that we have k over 2, and then we have x squared is over 2 for the first integral. I just add 1 to the exponent and divide it by 2, so x squared over 2 minus 4x cubed over 3, 4x cubed over 3. I just add 1 to the exponent again, and for the last one we have 4x to the power of 4 over 4, and that 4 will be cancelled as well. So over 4, and that 4 will be cancelled from a denominator and numerator, means that this 4 is cancelled, and I should put the value of the integral as 0 and half, means that first I should put half over it and then put 0 and subtract these two values from each other. So if I put half over there, let me erase the left side, that part of the expression. So if I just replace that value over there, then we have k over 2, and again let us put the value of half instead of the x. Then we have half square, which is 1 over 4, and it's divided by 2, so it will be 1 over 8 minus 4 over 3 times, if I put half cube is 1 over 8. Then also we have x to the power of 4, 1 over 2 to the power of 4 is 1 over 16. So if you just take a look on it, it's gonna be the value. This 8 and 4 also will be cancelled, and we have 1 over 6 at the end. So to find a common divisor between them, we can calculate it as follow. So we have k over 2, and at the expression that we have it, we should find a common divisor. So we have 6, 8 and 16, so it will be 48, the number that we have it as a common divisor. So 6 will be the value over here, minus 8 and plus 3. So at the end of the day, the value will be as follows. So 6 plus 3 is 9, minus 8 is 1, 1 over 48. So means that we have k over 48 times 2. This part is 1. So 48 times 2 will be 96. And this value should be equal to 1. So we found out that the value of k should be equal to 96. We found the value of k over here to verify that the given function is a actually joint probability density function over there. So I promise to show you the shape of this function as well. Let us take a look on that one as well. So let us take a look at the shape of this function. Actually, I used the desmos.com website to sketch the graph of this function. There are several applications in the internet that they sketch the curve or the surfaces online, but this platform, I like really this platform. Is totally user friendly, and you can use that one to sketch any type of the diagram or surfaces. So at the top you can see the several sides of this surface by using that function. So simply I just wrote over here z equal to 96 x, y, and the function is given over here. So as you can see, it's not positive everywhere, but the restricted region, even you can use that restricted region. And if I just extend it to 3D, you can see that what type of the cases do we have for for that probability distribution function. We have this region, and we calculate the area of this region that is equal to 1. And the remaining part is 0. So if I just sketch z equal to 0, which is the ground, then you can see that what is the form of a function. Means that in that region the green parts determine the probability distribution function on that triangular shape, and the remains are like that. I mean, from the top you can see that what type of the thing can be seen at that function. It's positive on that region, and you can see that region over here that is restricted in the given function. So at the next section of the question, as you can see, they ask you to calculate the probability of x greater than 0, less than y, and less than half. We want to calculate the probability of this region. So when the region is given, you should determine the region and find the intersection of a given region and the domain that we calculated before. We actually determined that domain before. So for determining the domain that we have it over here, we should sketch the shape of that domain as well. So as I said it, when we have the inequality, instead of the inequality we just replace it by the equality, and the result is y equal to x. So we should sketch the shape of that line as well. Y equal to x is a line that is passed through these points and with the 45 degree, and we can even find the intersection of that line and the given line 2x 1 minus y, 2x equal to 1 minus y. So to find the intersection of these two actually line, we should solve them in one system of the equation. If I just put 2x equal to 1 minus y over here, so instead of the y I can replace the y by x, then in this system of the equation I can find the intersection of these two lines. Means that over here I can see that 2x from the second equation, 2x equal to 1 minus y, and instead of y I can write it x. So then we can find the value for the x, which is equal to 1 over 3. So x is equal to 1 over 3, and because y equal to x, y also should be equal to 1 over 3. Means that the intersection that we have it is happen at the point 1 over 3 and 1 over 3. But the important thing is understanding the whole region that is determined by that inequalities. We have two more borders in that inequality. One of them is x equal to 0, another one is y equal to half. So for y equal to half, if you just take a look over there, y equal to half is a line that is located over here. Let me sketch it. Yes, we have y equal to half, y equal to half, and also x equal to 0 can be considered as a vertical line. Means that this is the x equal to 0, and let me just put it over here, x equal to 0. So right now we have three borders here. One of them is a green line, x equal to 0, one of them is an orange line, y equal to half, and another one is a brown line that is intersected by the 2x equal to 1 minus y, and we found their intersection. So the restricted region should be considered over here. If you just examine a point, for example, if you examine the point 0 and 1 to see that the upper part of the line should be considered or lower part of the line, then you can decide about the intersection of these two regions. And if you just take a look at 0 and 1, you can see that the x value 0 is less than 1, which is y value over here. So this part will be included in that inequality. So x is less than y determine all region that we have it above the line, not below the line. So the intersection between these two regions will be this green part. Right now I should calculate the integral over this green part. So let us calculate the integration over there. For that reason, let me just write the double integral. I will write the double integral over here. So this double integral should be calculated for 96 as far as I remember, xy dx dy. For instance, I can use the dx dy or dy dx, doesn't matter that which one should be considered over here. Let me just make that one bigger over here and construct the shape on that situation. So I sketched the intersection of this region separately over here to determine the region completely in this case, and as you can see I determine all of these sides and the edges over there. So the only thing that is important, and it's not discussed on the question before previously, is this point that you can see the value of y is equal to half, and it's an intersection with this line 2x equal to 1 minus y, and if you just put the half instead of the y, you will find the x as a 1 over 4. So we found all the edges and all the sides, and the order of the integration is dx dy. So when the order of the integration is dx dy, means that I should sketch the horizontal line to determine the integral. But as you can see, we have one border that we can go inside of it, which is x equal to 0. So the border that we can enter to that region is x equal to 0, and this is only one border. But from this point, if I just sketch the line over here, I can split the situation to two parts. One part is the upper part that the output or the layer or the border that we can get it out from that region is 2x equal to 1 minus y, and the another border is y equal to x, because we have two shapes over here. So because of that, to calculate that probability on a part B, we should split the integral in two parts and calculate the integral for two cases. Means that again I will write the integral over here 96xy. I will write it here 96xy dx dy. For the upper part, as you can see, the entry for that actually farmer or the people or the soldier, whatever you consider it, that enter to that region, the entry region is x equal to 0. So I will write x equal to 0. And the output is 2x equal to 1 minus y, or x equal to 1 minus y over 2. So it will be 1 minus y over 2. But the y ranges over here between this value 1 over 3. It started from 1 over 3 and it's ranging up to half. But for the remaining part, that is started, the y is started from 0 up to 1 over 3, we have the another cases. This is the lower part of this region. When we enter to this region, it started from y equal to 0 up to y equal to 1 over 3, that I just consider it over here. And the entry will be x equal to 0 again, and the output is x equal to y. So we have this integral for the part B, and we should calculate this integral to find the situation, to find the probability indeed. So I just write the step of calculating the integral over here. We just take a look quickly on that steps. At the beginning we have these two integral. The probability that we were looking for, that one means that the probability in the second part is equal to this addition of the two integrals. And first of all, 96xy dx will be 96x squared over 2, and if we divide 96 by 2, it will be 48 yx squared. So we should put the boundary 0 and 1 minus y over 2 for that integral. For the next one also, we have 48 yx squared when we put 0 and y instead of the x. And if I put the upper limits, means that 1 minus y over 2 instead of the x on the equation, then I have this expression that 2 squared is 4, and after cancelling 4 and 48, the result will be 12. And because it's a constant number is coming out, now we expand 1 minus y squared and multiply y one by the expression inside of the equation, which lead us to this equation. And 48 y cube as well is a result over there. When we replace y instead of the x squared, then it will be y squared times y, which is y cube. And the integral of y cube is y to the power of 4 over 4, that we should put 0 and 1 over 3 instead of the y to calculate that expression. So at the end of the day, we found the integral of that polynomial, and it was equal to this expression. Right now we should put 1 over 3 and 1 over 2 instead of the y to calculate that expression. And then we have these values over here. Instead of the x, instead of the y, I put half one times, and the another times I put 1 over 3 to calculate the subtraction. And at the end we have this calculation to reach to the probability that they asked in the question. We can even denote that place in the surface that we had. Let us take a look at the surface again. So I add that one in a program Desmos, and as you can see, the intersection of them is as the same as the things that we found. It means that this is their intersection, and you can see the color of that one as a gray from top. If you take a look on it, we just calculate this actually shape over here, and you can see what is the intersection of these two regions. You can even take a look on it. So I want to emphasize that for this remain part, means that this small triangle outside of the green triangle, the probability will be 0, and we didn't calculate that one. The only part that we interested in was this part, that we calculate the integral, double integral over this actually shape. So you can see the shape of that function as well, and as much as you solve more example, you get better in this concept. I hope that you understood the concept of the double integral and the joint probability distribution for the continuous random variable today. So thank you for your attention.